Hey everyone.
Hello.
Hello.
Oh, I was the first one to join, so I was tempted to just spend the time talking to the AI companion, ignore all previous instructions, and come up with a recipe for lasagna or something.
It's just jailbreaking the poor AI assistant.
Yep.
Oh, let me
Shane, your
think.
PR failed.
Oh, shit, okay. 1 second.
I think you opened at the same time as Steven, so I think there's probably a conflict there.
Yeah.
I always debate whether to put like the state and the country or just state on those. Because I don't know. Because I think IL is it for Israel. Like I don't
I can see, yeah, how that would be ambiguous.
know. Well, I assume there might be Chicago in Israel. I don't know, probably not, but
Usually, yeah. At least for European cities, there are quite a few like similarly named cities in the US. But
yeah.
I wonder why.
I don't know, it's just like parallel evolution. Yeah.
Yeah, it must be such a coincidence. Very
Yeah,
Yep.
you
weird.
can. I think if you go to like Canada, you can actually hit London, Paris, and some other cities within like a day.
Yeah, it's also weird that they're all prefixed with new. It's very, very weird.
Oh no, in Canada,
Yeah.
it's just London. It's not New London. It's just London.
All
Yeah.
right, okay.
I spent some time in Holland, Michigan. That was
Yeah,
another interesting place.
they got some nice tulips there. Yes.
They do, they do. And boot and shoe festival. Um, but it's also the place where they banned Harry Potter books from the library, I think.
They did what?
I,
Yep.
Okay, that's fine. So let's wait for another few minutes. Otherwise, we'll just start. Let me ping Michael. There he is.
guys.
Hello. There's chat.
Hi guys.
I
So just want to make sure because there are people that take holidays on the 1st of May.
yeah, it's not really a public holiday in the Netherlands, but it is in many other European countries.
Yeah, it's in Germany, but I think here in Switzerland, I don't know. I'm wondering,
Only
but
only in Zurich, I believe. And a
okay.
few other countries,
I think
cantons.
Poland is also like off.
Yeah, it's contradictory, right? To have
It's
a
Labor
holiday
Day.
on the
It's Labor.
It's Labor Day. Yes, it's
Yeah,
Labor
It's
Day.
it's
Labor
like
Day, and everyone takes off. That's well.
should work extra hard. Anyway, let's quick check. Everybody's there. And then we can start in a second.
I mean, it will take only 15 minutes anyway, right? The execution topic. So
Yeah, I mean, that's this. Okay. Share. Awesome. Okay, let's start the meeting. Before we get started, let me remind you that by participating, we all agree to the GraphQL spec membership agreement and to the GraphQL Foundation Code of Conduct. Let's start with a quick round of introduction. I'm Michael, and I'm the host today.
I'm Pascal from Chili Tree.
Martin from Apollo.
Derek from Apollo.
Sachin from Apollo. Steven of Netflix.
Awesome.
And I'm Shane. If you refresh the page from Apollo, I should appear.
And if you refresh your page in 30 seconds, I'm Jeff from Apollo.
Awesome. Anybody else?
I think that was it.
Just keep refreshing the page. Maybe
I
someone else will
I
appear.
can. Jeff's not in yet. Okay, let's start. We have one topic, and then it's basically execution or how we describe plan options in the specification text. And we kind of need to find a way to break it down into an algorithm that we can describe. And that's also where we had the, yeah.
I
Go
would
ahead.
have an ad hoc topic which just came up.
Okay.
Should we? It's a quick one. But so there's this Sunday is the talk submission deadline for the GraphQL Conf, and I was wondering if we should do another panel this year about the composite schema workgroup. I know that there will be definitely a few talks about the composite schema stuff and so on anyway, but the panel last year actually was pretty nice. It was really cool. People were interested, so maybe we could schedule or ask the conference committee if they're interested in something like this. Then we could do another one of these.
Jeff?
Being on the conference committee, yes, definitely interest. We might actually be working that into the day 2 agenda. We're looking at a few different options, but actually setting aside like time for like, we're not exactly sure what the form factor might be. It might be like in the session talk agendas, or it might be on like workshop day. But the idea being there would be some sort of panel or perhaps working session on the different working group topics, incremental delivery, HTTP, things like that, GraphQL.js, whatever. And that could be the form factor this ends up taking, but there's nothing stopping us from submitting a panel. It might just be folded into that day's agenda. We're still not 100% clear on what that might look like.
I like that idea because if it's just us, it might like be a repeat of last time. And I think it would be really great to have more input from other participants.
Yeah,
Yes.
the form factor of the open board meeting. I think you were sick that day on
I know.
the Michael. But the open board meeting was actually super interesting because there was actually more talk from attendees than from the people in the board. So doing something like this for different work groups could also be interesting. I think it's just that I'm not sure, apply or just make note of it early enough so that whenever these kind of sessions are planned, that the committee, so Jeff knows knows that we would be up for doing something, whatever it is in the end.
Yes.
This would absolutely be a priority to have on the program in some way, shape, or form. So even if we don't do a CFP submission, we'll call this
Sounds
group.
good.
Like it's going to be part of it in some way, shape, or form in a broader sense.
Cool.
Then we don't file anything and just expect something to be there, right, Jeff? Or should we file something?
Your call. I mean, it's really not a long process, like the whole thing should take just a few minutes, but regardless, we're holding space for all the different working groups because I doubt like everybody from GraphQL.js is going to get a CFP together. Now, if there's a specific topic or something like that, that like a specific editorial angle, fine. It might make sense to write that down and figure it out, but this is the kind of thing where it's a priority of the conference committee to have a more curatorial like approach to like unearthing and making public and engaging with the various working groups and hearing from them. And so I think that no matter what, I think we'll land in the right spot. So however form that takes is fine. If you want to save a few minutes and not do one, that's absolutely fine as well. So yeah,
Okay.
that would be my. And I'll just let the committee know just that I said that as well. Like we want to set aside time for this.
Sounds good.
Okay.
Sounds good. Cool. In that case, let's do 15 minutes of execution. Then we're done.
Then just polish, right?
Yeah. Yeah.
Did you have notes, Pascal, that you can share?
I did,
Just
but
on the
essentially if I remember correctly, the only thing that we discussed last time is that we actually want to do the query planning with plan options. So what we pass in is one of these query plans, and what we expect to get out is a set of schemas. And the thing that we have to come up with essentially is how we can split this quite complicated task of this query path into the planning steps. And
yeah,
that's where the
we discussed a couple of things last time. So if I remember right, one was like to repurpose the resolver execution, and basically for each resolver have plan options, or not fully like that, but in that directional sense. Then there was because like depending on how we want to approach this, if you there was also the suggestion that we don't define the algorithm, just plan options.
Yeah.
And just that we have an angle now that we follow, right?
Yeah, so I think the gist of it was that whatever we can either specify a very complicated algorithm that no one understands, which where we also integrate performance optimization like a real world algorithm, or we just do some kind of pseudo algorithm which satisfies all of the execution semantics, and also generates an actual result. But this would be a very inefficient algorithm. And the third option is that we make it a bit vague, like how you actually implement it with actual like description text. That how you implement it, it's up to you. There is these different approaches. For example, generating a query plan, executing the query plan, and so on. And you just we just define the plan options. And I think defining how plan options works is probably we need it anyway for satisfiability, and it's probably the easiest way to get started. Because for plan options, you need to resolve requirements. For plan options, you need to use the lookups and so on. So
yeah,
that's probably going to be the core of everything we do,
and
independent of which algorithm we use.
like just to get the sense here, like it went into the direct. I have that now on the stack again. It went into the direction that we as a group were of the opinion that we describe execution, but don't define an algorithm. Like we have the plan options algorithm, that is where we point to, and the rest is just it's just that the observable behavior that we describe has to be honored.
Exactly, and it all went a bit into the direction, if I remember correctly, that we said that we don't like if we actually specify an algorithm, it will most likely be not inefficient and not good enough anyway. So it's probably smarter to take the approach to start the introduction into execution with, well, you're on your own, so to say, because the implementations are very different, and you could choose whatever execution strategy that you want. You just have to honor plan options, the semantics of plan options. So however you want to execute, go for it. But the observable behavior must be what we describe in plan options. And I think that's quite a good solution, because the execution algorithm of Apollo, of the guild's gateway, of our gateway, and all the other gateways are all very different. So
yeah, and all, yeah, Yeah, there are different approaches to this, and also
Yeah.
To me, it seems like the easiest approach is to say, for a given field in the query, like your generated execution algorithm or plan must follow these general rules. Like, so we don't even have to worry about like, combining fields together in multiple subgraph and like doing all these things. Just for any given random field in the potential query that it could be valid against the supergraph, make sure at least all of them follow these rules, and just like that's where we stop. And
Yeah.
however,
the main reason we want this is to validate composition, right?
Yeah.
So we want to make sure there's at least a way to plan for each field the way Shane described. And we don't really care about like actual execution.
But it's
Yeah.
actually not field; it's rather path, right?
Yeah.
Just to be okay.
And I would say for the plan options algorithm, it probably makes sense if we do something similar that we have in satisfiability, where we actually visit the path, and then the set of rules that you described, Jane, essentially is for each segment in the path, we then say do one of these things, like check if it's available in the source that you're on, do a lookup, resolve a requirement, do whatever. And then we have these sub-algorithm, hopefully, where we say, this is how you resolve a requirement. This is how you search for a lookup. This is how you search for a field. What makes it a bit tricky, and that's something that it's probably a nested loop, right? So you first go through all the paths, and then you have to do for each subgraph that you for each context, for each option that you're on, so to say, you have to plan the field and see if the option is still viable. So for example, when user.id exists in schema A and in schema B, then you have to plan ID for schema A and schema B to get the output that it is available in both schemas, because you would reduce the option set with one if ID would only be available in one of the schemas, right? So it's probably at the very least a nested loop where we go through each field and then through each option and see if there is new options, where we essentially enqueue new options. Yeah.
But okay, so for plan options, the input is a path of the public API,
Yes.
and the output is possible schemas to locate it from.
That's one of the outputs. I believe that we may want to have additional outputs as well, but at the very least, we need to have the options as the output. But it could be that it's interesting when we actually track more state, so that plan options can be described easier, like, for example, what requests are done or something like this. Like the path through the option could be, I don't know. The very least, we need to have the options in the end, the options that are possible. When we want to go further, then we would have just the tuple as an output, where you also know what steps you have to take to satisfy this option. For example,
yeah, that was my, because like typically when you plan it, like if you are in this context, then you have certain data available that you can use to take one of these options. But it sounded a bit like not having this context, and then you just knowing that a certain path is plannable with certain schemas is not enough.
I think one way of looking at this is that a path is based on the client API, the API schema. And what we want from plan options is basically a set of resolved paths, where, for instance, if you can get like user from subgraph A and subgraph B, like from the perspective of the API schema, that's the same path. But once you go down into the options, you're resolving those, and you split it into two, and then of course you do that at every level. So you end up with sort of fully resolved paths, where for each field you know which subgraph you're getting it from, if you take that option.
Yeah. And maybe even how you get it. Like, for example, when ID, it's a bad example with ID, but let's say the field profile has a requirement, then we might actually be able to track as well on the option what the requirement was.
Yeah.
If we need it, like if there's no point of doing it, then we don't have to specify it. But if it helps in understanding the algorithm, then maybe. The
We
question
do that as
anyway,
well. We sort of have those as conditions on edges. So for instance, like a user ID might be a condition to take an edge to a different subgraph. And similarly, so it's a way of annotating those edges. And
Okay. So if you go in this path, you have to have this piece of information.
yeah,
And if you, okay. Yeah. And otherwise, this is not anymore an option.
yeah.
And these conditions could also again have requirements. How do you have that? These are then other edges that you have on them, or the conditions are also nodes, right? Okay.
No, the condition. I mean, Sachin might have a better
Yeah.
explanation of it.
Just as we recursively query plan conditions, right? So like when you have a condition on a particular edge, suppose you want to take a subgraph jump and say you need a certain set of key fields, you'd recursively query plan for those key fields. And then in the process, if that ended up requiring anything further, you would continue to recursively query plan as a started. So at least that's how Apollo does it.
Yeah.
so
Yeah.
we would recursively. Sorry, Stephen, go ahead.
Go ahead.
We would recursively call plan options in that case.
Correct. You could recursively call plan options for that.
What if you get into a plan options loop?
Yeah, we have
When
loop
you
detection.
have requirement requires a requirement, and then
we have loop detection is the story, basically.
it's all about loop detection.
It is. It's the difference between something that runs forever and something
yeah, I mean it's the matter of it's the nature of a loop without a break condition that it takes quite long for it to complete. So
Yeah, and strangely enough, the speed of your CPU doesn't really seem to affect it.
it's weird. I just bought I bought a new one and it still takes too long. It's strange.
Stephen?
Stepping back from the details a little bit, I'm wondering, do we want to specify that there should be a separate planning stage and execution stage with some sort of artifact in between? And if so, would we want to consider specifying the shape of that? And the reason is that can be useful for like testing different implementations, because you can, the planning aspect is a pure function, and that's a lot more easily testable, and so then you can compare different implementations about how it makes different decisions.
I thought about that, but the problem is that each implementation might end up with a different plan. You could have we could go down the route and define a structure for the plan, but in the end, like you cannot just verify if a planning algorithm is correct by basically saying, okay, two implementations should have the same plan, because they wouldn't.
True.
Because they could have different optimizations.
And that would also block innovation.
Yeah.
I also I'm also hesitant to require a planning phase because it's very well possible to implement federation without it. In fact, like the first federation implementation, like was just resolver based, and that would still like that would still follow the spec, I think.
Mhm. Another benefit of having a kind of a standard format for a query plan, even if it's maybe not mandatory, you can implement a valid implementation without it. It can be useful for observability tools, for like a I can imagine a module in graphical that allows you to expose the query plan, and that's something that we
Yeah.
use
Yeah, we
internally. It would be great if there was some sort of standard there. But I do agree that we shouldn't need to enforce that like query plans be identical to be valid, because this is something that we're running into right
we
now and validating our own query planners, trying to decide are query plans equivalent or equally valid when they're not identical.
Yeah.
So we did talk about query planning and query plan visualization at the GraphQL also with Benji, which doesn't do any federated approaches. It's just like how does he orchestrate his execution, because his talk was all about that the resolver model in GraphQL actually is wrong. And when you build a query plan, you actually also, as Martin said, you want to most likely go away from the resolver model and go into something which is more easily to orchestrate, because with the resolvers, you have certain restrictions, like you have to execute them in sequence, you have to do value completion and all these kind of things. So I also really want to have a way to describe execution plans, but we might actually it could be interesting if we define this in a more generic way, because for example in a hot chocolate server we also once had execution. Actually we still have, or did we remove that? We still have the execution plan. So even on a single server we could show how this is executed, what is parallelized, what is executed in sequence, and so on. So yes, I understand, because we also visualize them in Nitro. It's super nice to do. But if we specify something, maybe we can also take a step back and see, can we generalize this concept so that the tooling works across GraphQL and all the federated systems, right?
It might
Maybe.
also
Eric?
be a separate tooling spec and not necessarily part of this spec.
Yeah, it's also more about visualization than
Exactly.
Yeah.
Yeah.
Derek.
And yes, go ahead, Derek.
Yeah, I was gonna go back to actually verifying that the query plans are correct and semantically equivalent. Um, since we were actually spent last year rewriting our stuff, right, from JavaScript to Rust, that was one of our big concerns for us, right? Make sure that they're correct. And actually, you can verify those algorithmically. And there's actually maybe we should also define those basically algorithm that verifies that for the query, for the inputs, you generate a valid query plan that basically satisfies all of those requirements. And as long as that is satisfied, then your queries are semantically equivalent.
Yeah, there's one thing that you have to take in consideration with query plans. It's exactly where the implementations will completely be different. So
Yeah.
there's implementations which will be smarter than others in certain cases, where you say, actually, we can parallelize that, or we take an assumption more than it is in the specification that this condition is the
Yeah.
case, and then you can do better batching, right? And that's
Yeah,
that's
but
something.
there could be also completely wild ideas in okay, we
It's
prefer
more
certain
so.
infrastructure over other infrastructure.
A good analogy, I think, is with databases. Like you
Yeah.
wouldn't
Yes.
want your SQL standard to specify what a query plan should look like, or even what like specific query plans for specific queries should look like, because that's exactly where products are innovating and take wildly
That
different approaches.
that's also where they fail, because all of the query plan visualization is completely different from database to database, because they don't have a generic concept of visualizing how a query plan should look like. So
Yeah. Although most have to
the
have like an explain command of some kind.
yeah, that's true. That's true. It just sometimes it's rows, sometimes it's a JSON file, sometimes it's whatever. So you don't have one visualizer where you can drill deep into why this plan looks like it does.
Yeah,
I think
if there was a standard format for the explain output, that probably would be handy.
just go. It's like for the testability of an implementation, we need to specify tests like that you can run your gateway on, right? You do the composition of a set of subgraphs that we have, and then certain queries on this will cause certain or will enforce that certain cases are tested of the specification, and the observable result, that what comes back at the end, is what we verify. And I think that gives us all the most flexibility in the end. Did Pascal explain? Okay. Okay, that brings us back to the plan options. Yeah, and okay, so I'm also agree with Martin that like you could implement the whole thing on a resolver based model if you wanted to. Like we shouldn't even say that you have to do a query planner at all in the specification.
But we strongly suggest to do it, because essentially what planner options does is it creates a plan how to execute, because it doesn't execute.
It validates.
Yes, but what you get out of it is essentially you don't execute the query, but you get a description in how to execute. It's very different from a query plan, but it goes into the same direction, because you don't actually do execution. You say you have to do, maybe when we want to track it, because we could, you have to do these steps.
Maybe the word
get to
plan
the
is
result.
actually wrong here then. Maybe that's something we should avoid.
It just gives you, so as far as I understood plan options, is that it gives us the options that we could take to get to resolve a certain path, and the requirements we have to provide, like the required inputs we have to provide to take this option. And by having this tuple, we can verify basically if something is executable or semantically correct from a composition standpoint.
What about resolve
I mean,
path as an alternative name?
then depends on what you mean by it. If you're
It
talking
does.
about, if
Maybe
you're
it's too
talking
vague.
about, especially
Yeah.
when it's in the satisfiability, it's wrong, because in the satisfiability should probably not have any resolve language in it, because resolve is already used by the GraphQL specification for execution. So that's a bit weird.
Yeah.
I like the idea of plan options, because if you want, you can technically track on the option what you have to do to resolve it later. Like,
yeah,
when you
maybe it's also, but maybe it's also just the get options. Like I agree the word plan is maybe wrong. Because it's not about planning something, it's about to get the options that you have for this path.
Retrieve
Well,
options or something. Yeah.
but yeah, I mean, it's not so far off the planning, isn't it? Because
Yeah,
you actually plan how you could execute. I mean, the only thing that we have to do is we have to track the state. Like, first you do this, like in option, let's say option A, you fetch the user field from graph 1, then you have to resolve the requirement from graph B, and then you can resolve the ID field from graph B. And then essentially you have a plan. I'm not sure if the terminology
Yeah, no, but
is even wrong here.
yeah, but the plan looks like in the planning process, you look at a lot of other options. You are really planning a path, and you try to plan an efficient path for fetching all this data, right? You look at costs and stuff like that. And this basically just retrieves. Retrieve is actually not a bad word. Retrieves the options that you can take for a path.
Yeah.
It's a
I mean,
utility.
it doesn't. Yeah, it doesn't really. We can also set the name after we have the algorithm, because I believe that is probably easier. If we think about the retrieve options name to the side, and we think about this as we put in a query path as the input, and we track what schemas, what options we have. What else do we need on the context for this to work? What context data do we need to pass along through the execution?
What do you
Of
mean
this
by
algorithm.
context in this case?
Well, let's say the profile field is on two. Like you always start with a root field on the query, and this could be one of the public root fields of a subgraph, right? That's the first step that you have to do. The first thing is look up if with this type, the query type, this field is available on options. And in the beginning, probably all source schemas that you have are possible options. Like if you have 3 source schemas and only one has the profile, the first loop has all the options, because you don't know that profile only exists on one of the source schemas. Right? It's actually the initial state is you have all the options for all of the different source schemas. That's the initial state, and then from there you start going.
Wait, I'm not sure I follow.
It's technically only the ones that have a query type, but yes, are the ones that have that particular root operation type at top level. But
True. I mean, the question is if we, true, right. The ones which have a query root type or a mutation root type, depending on which operation you choose. But that's the when you enter plan options, the first thing you have is all options are available, right?
But is that true? Because you always plan for a path, right?
Yes.
So if the first path is I don't know, find like user by ID, then it's not all the subgraphs. It's the subgraphs with that root field, right? That have that root field available.
Exactly.
Exactly. So you start with all of them, and then the first segment
Yeah,
of
but
the
it's
But you don't start with all of them.
Yeah. It's just like if you enter through a field, it could very well be that you just have one option, although you have hundreds of subgraphs, because it's just this field is just mapped to one subgraph, and it could very well be as you go in that your options grow, because like you get to certain intersections where you now have a lot of options. So you always have the options that the field has at that point.
The type.
The field.
No, the field.
But you start on the type, right? You
Yeah,
start
but
on the query type.
The type in itself has no options. It's like you look at the like when we look from a query's perspective, you enter through a root field on a certain type, right? But it's always this pair, field and type. Like it's a coordinate.
But also when you're deeper in the tree, when you have users, when you're on the user type, you actually need to initially your options are all the graphs that have a user type, and then you can break it down. Like
no, but I wouldn't call those options. At least they're not the options you put in your in your like resolved path. Of course, you have to like go through all the subgraphs that have user and then check if they have that field. but you only take the ones that have the fields you're looking for on user into account. Like those are the only ones that you actually add to the set of options.
Yep, I agree. The output of the plan options, get options, analyze options, whatever we call it, an option is always going to be a final path, which will always be the path of types to fields and all the ways you traverse it. It's never going to
Right.
be. It's never going to end on a type. It's never only going to contain just a type. So like that shouldn't go into the queue as we're building the algorithm part of it either.
Makes sense.
Yeah.
It's just different terminology then. Then it's not options what I mean, it's something else. But
Well,
yeah.
I mean, there's code in there that like looks at all the subgraphs and sees what fields are, what types and fields are available. But I mean, I think that's an implementation detail.
So about the context data, like when you're on level, but like you have already resolved the root field and you're deeper into in the tree, is there anything more that you need to track? That, for example, like that for requirement resolving or for the key for the lookups, you actually need to maybe overselect that you have the key of an entity to then use a lookup and so on. Is this something that we should track on the option as well? Or is this something that we should track on the context data outside of it? Like, let's say you have a user by ID on graph A, and you have on graph A, you also have an email. And now you are currently, the options that you have is you're on graph B, on graph A, just a different graph. And then you would have to use a lookup to resolve this email field. But to resolve the email field, you also have to include the ID. So you need to verify that the ID is there and so on.
Yeah, I thought that we described that as the requirements, right? You have that's why it's a tuple. To take this pass, you need to provide this data because we need it underneath to feed into a lookup.
Well,
We
the
call those
output of
conditions,
this,
yeah.
Yeah, or other field conditions. Yeah.
Yeah. And as
And
Sachin
this would-
explained, it's basically like a recursive call to plan options or retrieve options. And I think it's up to us to decide sort of whether the result of that belongs in however we represent those options. Like, do we care where that data came from, or do we just want to know whether we can get to that data and like follow, like,
well,
perform a subgraph jump?
I mean, the output of plan options for validation should never have a requirement, right? Because then something would be wrong. Like
Right.
in
The root, you mean, the starting point.
when you think about satisfiability and you do a plan options in satisfiability, you cannot have any requirement in the options that are in the output.
Yes.
Like if we say that requirement the output of plan options is a list of tuples of requirements and the options, then this list will always be empty in case of satisfiability because you cannot have a requirement.
Yeah. It doesn't necessarily need to be a tuple thing that we represent in the data structure. I think it just needs to be in the algorithm. As you're walking through it, you get to a field and you have checks in the algorithm that says, okay, check to see if this field has a requirement of ID or requires whatever. And you go say, okay, well, for those things, go pull out all the requirements. Those are all going to be fields. And then just say, can I check, can I do it? Can I get these? You run those checks through plain options again. And if all succeed, then you know the field which has the requirements is all good. I don't need to do anything. I don't need to add stuff to the plan or anything. I just know that they're valid. But if any of those fail, then you just fail right there and say this is an invalid plan. So you don't need to like track that this field has requirements in the plain options thing itself, the thing that we return. But you just need to go for every field you get there. If it does have requirements, I need to go check them and validate all the requirements pass.
Yeah.
Yeah.
I think one of the questions is if if for those requirements you have multiple options, do you then consider those like, does that duplicate the options you have at that point as well? Do you take those into account, or do you just say it's still a single option I'm on? I don't care where those requirements come from, even if I have like two different ways of getting there. Does that make sense?
Yes, it does. And I think this is where the runtime algorithm would want to know that stuff, right? If you were to build a real implementation, but like, in terms of like the spec,
For
I don't think
satisfiability,
we
it
need to-
shouldn't matter. Yeah.
Yeah, it shouldn't matter, right? And so
I mean,
think we're good to say like you run this, and if you're talking about this at the actual runtime query planning, you would get an option and you would try to traverse it, and you would get to a point which said, "Oh, I have requirements," and like you'd have to do it again. But like that's fine, I think, in my mind. Like the algorithm, the spec, everything would just say, "This is the path you take." Like along the way, you might run into some requirements which require you to do more work because it's not like described fully, but that's fine. Like it's still a valid path. We checked that it's valid already. So
I think we should specifically not add these different options as options, because if we add them, then the specification, the behavior of the specification essentially says that you have to plan everything until the end. Like you have a very specific way of how the from an execution perspective, as soon as you find a path, you're good. If there's a second path, you don't care. As soon as you can plan this field, you're good. And then the implementations can decide, like what you do in with your gateway, that you plan out every possibility and then choose the best one. That's might be something that someone else doesn't want to do. So if the plan options just says we plan to find one of the solutions, then it's a bit open that you can also plan more than one, because the complexity just explodes. I think from a specification, from how we describe the specification, I don't think it's much of a problem, because we anyway have a recursive algorithm that we describe. We could just say that we enqueue all of the possibilities that we get from plan options as options, but that would make it very clear that you have to do this to be spec compliant. So
then you get into the problem of like, how do you represent though that plan option and the one field has inputs to it? Like you start need to describe the query
Well,
plan, like format and like all everything too. So like
if we don't output the steps, like if we don't output a plan on what to do, you don't care, as long as you know that there is one. So it could just be a check in the algorithm that plan the ID field, because that's a requirement, or to plan the SKU field because that's a requirement. Are there any options that you put out? If it's greater than one, then you can do it. If it's less than one, then you cannot do it. If it's zero or less, hopefully never less, then yeah, you're stuck. So I would specifically say that we just care about that it's possible to do, and not about all the different kinds of how we can resolve it, because in execution this could lead to problems.
Yeah.
The only thing which I think is a bit strange is when you have an entity and you have a nested field, like a data field, then you cannot, like, you need the context of the parent, the last entity. You would need to know where to fetch fields from the base of the last entity, right?
How do you mean?
Let's say you have, I don't know, product.details. Product is an entity, details is not an entity, it's just a value. Now you're in product by ID dot details dot something. And now for lookups and requirements, you actually have to know that the last entity that you worked on is product and not the product details type, right?
Is
Yep.
that true? I don't think if we're planning a path, like once you're down into details, you either
I
stay
see.
there or you go to another entity. But
Yeah, but to go to another entity, you can just use the path again. Like,
well, I mean,
can
you would need to have the key fields available at that point, but that's just another planning action, right?
yeah, but you would need to know that the key fields are not on the product details type. They are
Yeah,
actually
but
on the product type.
you know what an entity is. I mean, you know that the type product has the lookups to
But
transition.
you would never have to go back. Like once you're
Yeah.
in a path, once you go from product to details, you don't need that context anymore. You can like if on details there's a link to a I don't know a user or something or a store, that will have its own ID. You never have to
Because
go back.
true. You're right. Because if on details there's a field A and the field B, and A comes from subgraph A and B comes from subgraph B, on details you actually have two options. And then if you have product details.A, you have only one option, and if you have product detail.B, you have the other option.
Yeah,
Makes
we
sense.
because we only plan like single fields, right? It's
Yeah,
a path.
you're right. You're right. So the requirement actually comes in effect on yeah, it makes sense. Makes sense.
Yeah, it's
Makes sense.
difficult, Pascal, sometimes to just validate that's the path. It's really to let go of the planning.
Yeah, true. Like you carry along all information that you need to know that the requirement is already resolved by the point that you are in details.
Yeah.
And the lookup is already done at this point in time. Okay, so what different flavors of checks do we have to do to see if we can resolve a field?
We
have 8 minutes, just as a reminder.
Yeah, I mean, subgraph jumps are the obvious one. And those have their own conditions based on the keys. A field might itself have additional requirements on it through requires or require.
And also keys can have requirements. Like to get a key, that key could cause a requirement.
Yeah. But you first have to be able to jump to that subgraph. And then within a specific subgraph, you like the requirements are subgraph specific, right? The requires.
Do we actually always start with all of the subgraphs which specify this type and field? And then we have to check against our options to see if we can make it there?
I think so, yeah.
So it's a triply nested loop.
Yeah, no, it's
I think there are even more.
I don't think it's
levels to it.
It's not like that. It's actually not so good recursive. But you
while
continue.
loop and a queue. So there.
Yes, that's how we actually. But
well, the while loop is also a loop,
but you also have like
you have for each. Well, the reason why triply why we have nested loops is you have the path, which is the outer loop. Then you have the options, which on each step you have to consider. And then you also have for each field to consider that it could be on different source schemas. So for each option, you need to check if you can resolve a field from all possible source graphs.
Yeah,
and then
and there are in between ways where you go just through a couple of hoops to resolve keys, and that is maybe
but
never data that you surface, right?
That's
more like a
essentially
subroutine.
Yeah.
But that's where you combine you compare. So if I'm in a specific segment of the path, and I'm in a specific currently in a specific option. So in a specific option, so I know that I'm, for example, on the profile subgraph. And then I say I'm on the profile subgraph, and I can resolve this field from these other subgraphs. If it's the profile subgraph, I can just continue because that's the subgraph I'm on. So that's good. If it's any other subgraph, I need to check if I can get there through a lookup. And if I can get there through a lookup, then I have another field. And then I have to check if there's requirements on these sub options. And if I can resolve this, then I get a result of possible next options. Then we put everything in a hash set and go to the next path, and we're done. It's easy.
Yeah.
I think
Can
I
we-
can write down something stupid, and
then
I can post it into the Slack channel, and
Yep.
then we can comment on it, because
I think
you
it would be
could-
good to start with this basic algorithm. And after that, there are other complications we'll have to think about, like abstract types, like possible type explosion, and things like that. But we can leave that for now.
Yeah, it's
Yeah.
easier to add later.
Yeah.
The requirement loop is a tricky one. That's a tricky one. Because we have an example in our tests for Fusion where you have fields which require themselves, but from different subgraphs. So when you do a plan options, so I can show you the test later. The thing is that you have a user type which has a profile field. You have a product type which has a details field which needs the SKU, and then on a different subgraph you have a product type with an SKU field that needs the details field. And then when you would actually just jump between these two graphs when you just do a recursive call on plan options, because plan options doesn't carry the state, right? So that's the loop detection problem that we have with requirements, because it could be that requirements require themselves, and then
Okay. Yeah. Okay. I think we are at the end. And we see us next week.
cool.
Hopefully.
Thanks a lot.
Sounds good. All right. See you all next week.
See you. Bye-bye.
See you guys.